Howdy guys, so in this video we're going to talk about quantiles. So let's consider a population of crabs where the length of a shell, x millimeters, is normally distributed with a mean of 70 and a standard deviation of 10. Our biologist wants to protect the population by allowing only the largest 5% of crabs to be harvested. He therefore wants to know the length that corresponds to the 95th percentile of crabs. So what that means here is if he's talking about the largest 5% of crabs, that's the 95th percentile. Okay. To answer this question, we need to find k such that the probability that x is less than or equal to k is equal to 0.95. So we're just finding what that k value is in terms of how long crabs are to figure out where that 95th percentile is. The number k is known as a quantile. In this case, it is the 95th quantile. When finding quantiles, we're given a probability and are asked to calculate the corresponding measurement. This is the inverse of finding probability, so we use the inverse normal function on our calculator. Now, to find this on your calculator, you've got to go to Stat in the menu. When you open that up, you'll go to Dist, which is F5. So the same as what we were doing before, you'll go to Norm, which is F1. And then instead of going to the NCD like we've been doing, you're going to go to NVN, which is inverse norm, which is F3. So if we look at this example here, we've got that X is normally distributed with a mean of 23.6 and a standard deviation of 3.1. Now we want to find K for which the probability of X is less than K is equal to 0.95. So what we're going to do is we're going to go to that inverse norm function. But before we do that, it's always good to sketch out, I'm in green because I had my highlighter in green, a curve. So what we're trying to do is basically find K so that this here is 0.95 or 95%. So we want to find this value here. So if we go to our inverse norm function, now if we go in, like I said before, so you go into Stat, you'll go to Dist, Norm, and then Inverse Norm, and you come up with a screen. Now what we've got is data, and we'll leave that as variable, as we've been doing the whole time. Tail. Now what that means, the tail here is what tail you're going to be looking at. So this here is the tail, this side here, because this is what we're looking at. So this is on the, what side? Left-hand side. So you've got to change that to left if it's on right. If you wanted to find the other direction, depending on how the question is worded, that would be the right tail. Your area. So your area is also your sort of probability, which is your 0.95. So if we go 0.95. Now our standard deviation was given to us in the question, which is 3.1. And our mean was also given to us in the question, and that was, what was that? 23.6. So if we put that all in and hit EXE, you should get that the probability, so you can say the probability of X less than K is equal to 0.95 is equal to, or we could say K is equal to 28.699. Now, if we wanted to go to three significant figures, we go to 28.7. So, also good, I probably haven't stressed this enough, but because we're doing probabilities and we've got lots of decimal points, it's good to use these equal signs, which means approximately. So we know that it's approximately 28.7. Now, we had no scenario in this question, so we can't give units. That would be all we need to do. Okay, so I hope that makes sense, but we'll look at a few more examples. Actually, I lied. I'm going to leave this video here because what we can do now is have a look at exercise 8F.1 and I'll make another little short video for exercise 8F.2 instead of combining them. So these are the questions that we'll do in class and I'll get the other video organised as well. Thanks, guys.